In this video, we're going to be reviewing how to compute the specific gravity of porous media. So as you see here, I already have several text written out. So let's go through it and make sure we know what we're looking at here. First, what is porous media? Well, porous media is just simply material with pores in the voids between solid particles. So anytime you hear the word porous media, you're thinking of material that has pores or dimples and voids between solid particles. So we think of things like aggregates, sand, crushed rock, and soil. So for example, if you have a little particle right here that has little dimples, and inside of those little dimples or pores, they can be filled with air or water. That would be porous media. So let's say we have another particle here and another particle here. And then, of course, we have little pores or dimples that can be filled with water, as well as water filling the void spaces between the particles. That's what we would call porous media. Now, specific gravity of porous media is computed based on the ratio of the weight or mass of a certain volume of the substance to the weight or mass of an equal volume of a reference substance. And that reference substance is usually water. Okay, so again, we're looking at the ratio of the weight of a certain volume of a substance to the weight of an equal volume of water, okay? And again, this could be based on weight or mass. We could see the weight version or the mass version of that. Now, in a previous class, maybe like construction materials, you dealt with different types of specific gravity calculations of porous media. So we're going to write this down. We're going to say that in construction materials, we dealt with oven dry, or sometimes abbreviated as OD, specific gravity. We also dealt with saturated surface dry, or abbreviated SSD, specific gravity. And then we also dealt with apparent specific gravity. So we saw three different versions of this in your previous course in construction materials. Now, how do we determine this? Well, in the laboratory, we would perform an experimentation where we would use like a special type of flask called a pycnometer. Pycnometer, pycnometer. And again, it's a special type of flask that looks something like this. So you would have this long neck bottle with a bulb here at the bottom, and you would fill it up with water up to a 500 milliliter mark. And you would usually use distilled water to perform this experiment. So let's go through the steps on how you would have done this in the laboratory. Step one, you would obtain the weight or mass, it could be a mass or weight, of the pycnometer plus 500 milliliters of water. So you would obtain the weight or the mass of this pycnometer filled to the 500 milliliter mark with water. And you would call that either W1 if it's a weight or M1 if it's a mass. Step two, you would then remove some of the water from this pycnometer and you would input, this is input, let me write that a little nicer. You would input a known mass of whatever substance you were interested in. So in construction materials, that may be sand or rock. That would be fine aggregate or coarse aggregate. And so the substance, whatever it is, fine aggregate, coarse aggregate, or soil in this class, is going to have a known weight or mass. Okay, again, you could do this based on weight or mass. And we're going to call that W sub S if you have a weight, or M sub S if you have a mass. So again, you're going to empty out some of this water to make room for the fact that you're putting in there some known mass or weight of your aggregate or soil. Then step 3, you're going to top off the pycnometer at the 500 milliliter mark with water again. So you're going to make sure that now you've got your pycnometer with your either your aggregate or your soil inside of it, and you have filled it back up to the 500 milliliter mark, and you are not exceeding 500 milliliters. And then you're going to weigh or get the mass of that pycnometer plus the material inside of it plus water filled to the 500 milliliter mark. And we're going to call that W2 if it's a weight, or M2 if it's a mass. So what you're also going to have to calculate is the weight or mass of equal volume of water and material. So we're going to make a little note here. We're going to calculate this. Okay. So let's look at a graphical representation. Okay. The first thing you're going to do is fill your pycnometer to the 500 milliliter mark, and you're going to get its weight or mass. So you either get it as weight, W1, or mass, M1. Then what you're going to do is you're going to take a known weight or mass of your substance. In this case, maybe it's soil, maybe it's sand, maybe it's rock, whatever. You're going to know this mass, and then you're going to insert this mass into your pycnometer. Now, before you just put that in the pycnometer, of course, you need to empty out some of this water. Otherwise, you're going to get water kind of shooting out the top here and spewing out. So you need to empty out some of this water to physically make room to put this dry material into the pycnometer. And then you're going to weigh this pycnometer that includes your dry material, which is now wet, of course, and then filled back up to the 500 milliliter mark with water. And you'll get that weight as W2 or M2 if you get the mass version of it. And then we're going to calculate the equivalent weight of water as W1 plus W sub S minus W2. Okay, so it's the weight of the pycnometer filled to the 500 milliliter mark plus the weight of your dry material minus the weight of the pycnometer filled to the 500 milliliter mark with your substance inside of it. And of course, we can get this as a weight calculation or a mass calculation, depending on how you're measuring things. So again, this is a bit of a review because you would have done these calculations in your previous course, and you would have done these calculations pretty much the same way, whether you did oven dry specific gravity or apparent specific gravity or SSD specific gravity. Now, depending on which one of those different specific gravities you were calculating in construction materials, you may have slightly added or subtracted different types of measurements here, or your numerator of a fraction you're going to calculate may have been a little bit different. But essentially, it's a similar kind of calculation, whether you're looking at OD specific gravity, SSD specific gravity, or apparent specific gravity. So that should be a refresher to you. And when we get into the classroom, we're going to do a numerical example of this, and then we're going to see this done with, in a hands-on setting in our laboratory. So that concludes this review video.